Hello everyone, my name is Kamal Thapa and I'm here with my video presentation on my final course project. My project is on hand operated sharing machine. The project overview is like I've designed 8 hand operated sharing machine. I have tried to implement the design for manufacturing and design for assembly, and I have redesigned parts on the basis of DFM and DFA. I have prepared manufacturing plan for a part. The part is a handle support. Similarly, a Creo Parametric has been used for solid modeling and manufacturing plan. So out of this project, there were some results. I was able to reduce the number of parts. I was able to increase the work range for the product, and the final product was easy in the assembly. So solid modeling is basically the 3D representation of solid objects in the computer. Those solid models contain all the information that a real object would have. For example, the volume, density, mass, inertia. There are some advantages of the solid modeling. The few are enlisted here is it is complete modeling. It is unambiguous. That means the ambiguous models cannot be created. It is very suited for the automated application. The part creations are very fast. Similarly, it gives huge information. But there are few disadvantages of solid modeling as well. It requires large memory and the manipulation is quite slow. What is Creo? Creo is basically a parametric feature-based modeling system to design, analyze and manufacture almost unlimited range of products. Feature-based modeling system basically means that the part created are through features like extrusion, holes, cuts, sweeps. Similarly, the parametric means that the physical shapes of the parts are driven by parameters. Those parameters are usually dimensions. So these are the parts in the seat sharing machine. This is the body frame, this is the bolt, this is the handle, and this is the handle support. This is the lower shear blade, this is the upper shear blade, nut, blade support. This is the washer, this is the bolt for the safety stop. So these are the two parts that make the safety stop. This is the lower part, this is the upper part. So I have implemented design for manufacturing in this project. Design for manufacturing basically means the design of the parts so that the manufacturing becomes easier. There are few advantages of design for manufacturing. DFM, it helps to design for the ease of manufacturing. It reduces complexity of the manufacturing operation. It reduces the manufacturing cost. So the basic DFM guidelines I have implemented in this project is to reduce the number of parts, design parts to be multifunctional and multi-use, design for ease of fabrication and use of standard components. As we know that in sheet metal design, the diameter of the hole must be greater than the thickness of the sheet. So parts like handle support, upper shear blade, lower shear blade will ensure that they possess these characteristics. This is our safety stop. It consists of two parts, the lower part and the upper part. So I have redesigned this part so that it consists of only one part. So this was done in order to reduce the number of parts. This was one of the design modifications. This is our lower shear blade. The original product is able to cut from this surface only, the upper surface. So I redesigned this lower shear blade so that this lower shear blade can cut from this upper surface and lower surface. I realigned these holes and fit it with the body frame. The advantage of having two cutting surfaces is that we can get different edge finishes. Similarly, this is the body frame. The original product was able to cut the sheet metals only, so it the original product didn't was not able to cut the rods. So I was interested to shear the rods as well. So I created a hole in the body frame and in the upper shear blade so that the rods also can be sheared. This is the figure of the assembly of modified body frame and upper shear blade. I have also implemented the design for assembly in this project. Design for assembly basically means to design parts, assemblies and sub-assemblies so that the assembly cost can be reduced. There are few advantages of DFA. It reduces the number of parts, it improves the quality and reliability, it helps in the reduction in production and part inventory. So basic DFA guidelines implemented in this project are designed for ease of fabrication, designed for ease of assembly, minimize the number of parts, use of standard parts, designed for part orientation and handling, color code parts that are different but shaped similarly, mistake proof product design and assembly. So in this safety stop in the original product, it has a circular hole to fasten it with the body frame. So so I redesign it with oblong hole so that it can be fastened with the body frame quite easily. So this redesign really helped for the quicker and easier fastening of the safety stop with the body frame. Similarly, the holes in the handle support and handle was larger or bigger than required, so I redesigned it with a smaller hole in the handle support and in handle as well. This is the redesigned bolt for the handle support. So the final thing done in this project was preparation of the manufacturing plan. So I chose handle support for this. The manufacturing plans consist of three sequences. The first one is the hole making, the second one is the volume milling, and the third one is the surface milling. In the hole making sequence, two drill groups were created since there are three holes. First one is the two 10 mm diameter holes, and it used the basic drill tool of 0.3 inch diameter. Similarly, the third one which has 5 mm diameter hole has the basic drill tool of 0.15 inch diameter. The second operation was the volume milling. Volume milling is done in order to remove the materials from the workpiece, and for this mill window was created, and the tool used was in mill of 0.2 inch diameter. The last operation in this operation was the surface finishing, in order to get a smooth surface finish. The same mill window that was created in the volume milling was used in this operation as well, and the tool used was the in mill tool of 0.15 inch diameter. This is the picture of the how it looked at the end of the operation. This is the final result of the manufacturing plan. So in conclusion, the parts were analyzed and redesigned based on DFM and DFA, and manufacturing plan was described for handle support, and the number of parts were reduced, and the product quality and usability was improved. Now let's see how my assembly worked. This is the final assembly, this final model, and it works like this. This is my final, and this is in the hole in the upper shear blade and body frame has to shear the rod also. Similarly, let's get the original model. uh, let's This is our original model. The last one is the modified one. This is our original model, and we have this part. This is our safety stop. It has two parts, and it functions like this. It is movable part, and it functions like this. Similarly, the handle also works exactly the way the redesigned assembly worked. This is the final output. Thank you.